Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in the Department of CSC at the Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about Dijkstra algorithm for finding the shortest path in graph. So when it comes to the Dijkstra algorithm, so this algorithm is derived by Dutch computer scientist E. Dijkstra in 1956 and published in 1959. So it is a graph search algorithm that is going to solve single source shortest path problem for the graph with negative edge paths cost and then produces a shortest path tree. So this algorithm often used in routing as a subroutine in other graph algorithms also. So Dijkstra's algorithm is derived by the computer scientist Dijkstra in 1956, and it is a graph search algorithm that is going to solve the single source shortest path problem and other kind of problems also like all page shortest path also is there. So for that we're going to have a different kind of algorithm. So mainly this algorithm is going to be used in routing and as a subroutine other graph algorithms. So how it works? So this algorithm is going to find the path with lowest cost. So between the vertex and other vertex. So for example, if I'm going to have the vertices of the graph represent the cities and edge path cost represent the driving distances between the pair of cities connected by direct road. So for that kind of problem, so distance algorithm is going to be used to find the shortest path between one city to all other cities. So according to the algorithm, so how to solve a given problem, we need to solve different parts of problems. So how it works means that so this algorithm is going to find the lowest cost between the vertex to the other vertex. So for example, if I'm going to have the vertices of the graph is going to represent the cities and the edge path is going to represent the cost that is associated between the cities. So I want to find what should be the shortest path from one city to other city, how to find. So normally this algorithm is used to find the shortest path with one city to other cities. So according to this algorithm, I'm going to solve a given problem. I need to solve different parts of the problem. So numerical algorithm is that. So formulae. So formulae is that. So big O estimate of mod v square plus big O estimate of e. And here, so finally I'm going to get big O estimate of v square. So when e should be the edges and v should be the vertices, and mod v should be the function of edges and mod v should be the function of vertices and O should be the constant. So we're going to have a graph algorithm like this. So in this uh, graph, so the vertex will use. So here each vertex is going to represent the cities, and these are the costs that should be associated with each city. So in order to start this algorithm, so what I'm going to say is, so have to be start from the decided vertex and then have to be continue. So whether I have to start from this vertex and have to find what should be the shortest path to the remaining cities, or I can able to start from here, I can able to find what should be the shortest path to the all other cities like this. So I'm going to start here in this step onward, so finding the shortest path. So for that, what I'm going to say is, uh, so for that I'm going to construct a graph here, like set of vertices as the cities here, right? So I'm going to start from A. So from that, I'm going to find out what should be the shortest path from source A to all other cities. So if I'm going to start from A, so I have to find what should be the shortest path from A to B. So A to B, that should be 20 is going to be represented, and similarly from A to G and A to D. So for A to D, so I'm going to have 60, so totally 80 I'm going to get. And similarly for reaching this, I'm going to get 90 here. So this should be 60 here. And like this I have to find out. So from source vertex to all other vertices and all. And from A, so what I'm going to say, from B I have to find it out what should be the shortest path from B to onwards I want to find. So from B to A, what should be this value 20, and then B to A again, B to D. So for B to D, what should be this? It should be 60 plus 20, so that should be 80, and B to F, uh, so 20 plus 10, 30, and B to G, so 20 plus 90. So from the source vertex from B onwards, I have to find what should be the shortest path from B onwards. So from B, I'm going to find, so B to D, how much I'm going to have 620 plus 60, that should be 80 here, and then B to F, so 20 plus 10, that should be 30, and B to G, that should be 90 here. So from F I'm finding, so what should be the next shortest path. So from F to A it should be 20, and F to C, so how much it should be, so 20 plus 20 plus 20, 10, 10 plus 10, that should be 40 here. And similarly from F to D it should be 20 plus 10 plus 40, so that should be 70 here. And similarly from F to B it should be 30, and then F to G it should be 90. And similarly from this, how to choose from C. So from C, from this, I'm going to find out the what should be the next minimum path I have to find. So for this, uh, so from C to A, I'm going to choose. So this is the shortest path. So from C, it should be 20, and C to F 40, and then C to D, it should be 50 here I'm getting, and C to F it should be 30, and C to G it should be 90 here, and C to H it should be 20. And from D, so I'm going to choose D here. So from D, what I'm going to say, so from D what I have to find here is that, so from D to C it should be 50 is getting, and D to B I'm going to get D to F, it should be 40, and D to G it should be 70, and D to H it should be 10. Similarly from H I'm going to find out, and similarly I have to find from G onwards. and then finally have to construct it. So finally, like this, we're going to find out the shortest path from one node to the other. So for this algorithm, so what is the path I'm going to get is, so A to B, B to F, C to D, D to C to D, and D to H, and then D to G. So the total cost should be the sum of that. So it should be the lowest cost here. So what is analysis technique uses algorithm in a network analysis. So this is the way of finding the Dijkstra's algorithm. So in Dijkstra's algorithm, so this was invented by the computer scientist Dijkstra in 1956, and this should be a graph search algorithm that is going to find the single source shortest path problem, and this algorithm is going to be used in routine and other as routine graph algorithms also. And this algorithm is going to find the lowest cost between the pair of vertices, and according to this algorithm how to solve different kinds of problems also. And this is the formula what I'm going to follow here. Suppose if I'm going to have a cities like this, so simply if I want to say this, so 10, 20, 15, 25, 30, 50, 10, 20. So for single source shortest path one have to find. So for this, we should have to choose one vertex here. From this vertex, so what is the minimum path I have to find here? So minimum cost. So that's why I'm going to move from A to C, since this should be the minimum one. From C, what I'm going to say, it should be 30 and 25 is there. So that's why I'm going to choose this one next, C to B. And from B, I have to choose the next minimum, that should be 10 is there. So B to E, and from E, C to C is the only thing I'm going to have, C to D, and from D, so this is the single source shortest problem where you can able to visit all the vertices or nodes here. So what is the cost here is associated 10, 20, 25, and then 10 plus 20. So what should be the total of this? That should be 30, 40, and then 65. So 65 is the minimum cost that should be able to find according to this algorithm. So similarly, in similar fashion, I'm going to construct this one. So according to this algorithm, so this is the graph of cities and then where the cost is associated with this. And from this, I'm going to choose the shortest path from the one city to the remaining all the other cities. So from this case, what I'm going to say is, so first I have to find what should the cost from A to B, and then A to B and A to G. So from B, I have to find it out. So what should be the next minimum? So B to F, so it should be 30, 20 plus 10, and B to A, B to D, it should be 80, and from B to G, it should be 90. So similarly, I'm going to find from F. So similarly from F to B, so it should be 20. And similarly, I want to find from C, D, H, and then G. So these are the ways we have to find the shortest path, and this should be the point that is going to be obtained. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.